Hi, my name is Prakash Gupta, and this is my Physics 2212 Lab 4 video report. Introduction and purpose. In this lab, we're going to work with Faraday's law, and we'll study the interactions that occur when a magnet falls through an aluminum tube. After observing this interaction, we'll build a glow script model, and this will help build our skills in taking measurements and building computational models. First, let's watch a video of our magnet falling through our aluminum foil tube. We can see that the magnet moves much less quickly through the tube than it does once it's out of the tube. So clearly some force is being exerted upwards. Now let's look at our model. So the first thing that we needed to do was set our geometry of the tube, and we used a tape measure and then conversion from customary to metric to obtain these values. We also used our dipole function from the previous lab, and we developed a flux or change in flux analytic function, which you can see at the bottom corner. We also needed to determine our forces on the ring, and we also wanted to, once we had done that, we needed to use Newton's second law to determine how this changes over time, and that created our model. See here our bar magnet at the top, preparing to fall down through the tube, and we can see here velocity versus time, showing that it's going to increase in velocity and then decrease in velocity, and on over time. We can see up above that there is a far zoomed out, that this kind of converges to that much more stable fluctuation, oscillation of velocity. And this shows us how we, over time, are slowing down within that ring. Now let's address some what-if questions. So what if the resistivity of the conductor were reduced as close to possible as 0? So if the resistance of the conductor were reduced, we'd know by Ohm's law that the um, current would have to rise to compensate for that to maintain equivalent voltage. And that means that the induced current is much greater, so the amount of force that it will then apply back onto the magnet to keep it from falling so quickly will be even greater. So our magnet will fall even more slowly. Now, what if there were holes or slots cut into the tube? How would this affect the ring currents in your model? So if we have any slots or holes in the tube, we know that this will disrupt the current at any given Y level or Z level, whatever, what have you. And any disruption in this current, any break in the circuit, would totally impede the flow of current there, and that means that there would be no induced force upwards um, back on the magnet, meaning Lenz's law would not apply here. Now, there's one caveat to this, which is that if the holes or slots were significantly smaller than the size of the magnet, it's possible that this would not have an impact. All right, thank you.